Assalamu alaikum guys, and this is Mohammad Shahriar. Welcome to DSA Master. In this video we are going to solve a LeetCode problem 169 majority element. By solving this problem we are going to learn Morse voting algorithm. So what is given in this problem? So given an array nums of size n, return the majority element. So you will be given an array of integers, and the size of the array is n, and you have to return the majority element. Now what is a majority element? The majority element is the element that appears more than n divided by 2 times. So here they used floor function. That means you have to take the integer part of n divided by 2. Sorry. So what does it mean? So let's say we are the n is equal to 8. Then what is n divided by 2 floor? So in that case, this is a perfect division. 8 can be divided by 2, so the answer is 4. So we are not seeing the actual functionality of this floor function. So in that case the answer is 4. So n divided by 2 is 4. But if we have an odd number like 7, this is not a perfect division by 2. So and we do this n divided by 2 floor, then when we divide 7 by 2 is this something like 3.5. But in that case, when we use floor function, we take only the integer part. So we are only taking 3. This is the answer. So when we are dividing 9 divided by 2, we are getting 4.5. But if we say floor, we are only taking the 4 and we are removing the fractional part, or the part after the decimal point. So this is the case. So n divided by 2 floor or integer part you have to take, and the question said that the majority element is the element that appears more than n divided by 2 integer part. That means let me show you an example. So let's say we have an array 2, 3, 2, 4, 2 and 2. So here the size of this array is n equal to 6. Sorry. So what is n divided by 2 floor? This is 3. N divided by 2 floor value is 3. And what is the greatest frequency of which element is appeared more times? This is 2. 2 appeared 4 times. And 4 is greater than 3. That means in this array 2 has appeared 4 times, which is greater than n divided by 2 floor. That means 2 is the majority element of this array because it appeared more than n divided by 2 floor, or floor n divided by 2. Let me show you another case in the same example, kind of 2, 2, 3, 2, 4 and a 6. Now n equal to 6. The number of element is 6. And what is the maximum frequency element? This is 2. 2 appeared 3 times. So 3 times. What is n divided by 2 floor here? This is 3. Now 3 equals 3. That means 2 appeared n divided by 2 floor times. And this is not the majority element. It should be greater. It should be greater. So let me show you another example of odd number of elements. So 2, 3, 2, 4, 2, 6, 2. Now what is the number of elements? 1, 2, 3, 4, 5, 6, 7. 7 elements we have, and what is the maximum frequency element? This is 2 still. 2 appears 4 times. 2 appeared 4 times. What is n divided by 2 floor in that case? 7 divided by 2 floor. What is 3? So 3 is the n divided by 2 floor value, and 2 appeared 4 times. That means 2 appeared more than n divided by 2 floor times. And that's why 2 is the majority element in this case. Okay, we got what is n majority element. Now they say that you may assume that the majority element always exists in the array. That means there won't be any case that the majority element is not exist. For example, this array. In that case we don't have majority element, but this case won't exist in this problem. That means we will always have a majority element. Now our task is to find that majority element. That means, let me repeat again, you will be given an array nums that has size n. You have to find the majority element. What is a majority element? The majority element is that element that appears more than n divided by 2 float times. And it is guaranteed that there is a majority element and you have to find it. Okay, so now let's see constraints. N will be 5 into 10 to the power 4, and the numbers will be minus 10 to the power 9 to 10 to the power positive 10 to the power 9. Okay. And this problem could be easily solved using hash map. Okay, if we solve this problem using map, we know that map has complexity of log 2 of n. So overall complexity will be n log 2 n, overall time complexity, if we use map. And overall space complexity will be order of n, because map will take all the n elements and we will count how much time it appeared. Then we will search that is it the most frequent element, and is it the it appeared n divided by 2 more than n divided by 2 floor times or not, using map. So the time complexity will be n log 2 of n, and space will be big O of n. And if we use unordered map, something like that, so the complexity of unordered map is average case big O of 1. So overall complexity will be big O of n, and still space complexity is big O of n in that case. But we have a follow-up. In interviews we have follow-ups, and the follow-ups makes the problem critical. So this problem is too much easy using map, but there is a follow-up. Could you solve the problem in linear time and in constant space, big O of 1 space? That means this solution won't be accepted in your interview if interviewer asks this follow-up. So in that case, this case has time complexity n log 2 of n and a space complexity of big O of n. But we have to solve the problem in linear time, big O of n, and a constant auxiliary space, big O of 1. What is constant auxiliary space? That means in this problem we are given a vector. We have to give a vector because we are taking an array. Okay, so this space cannot be skipped. But rather than this, you cannot use any extra vector, map, set, something like that. So this is auxiliary space. You cannot use it. You have to solve it in big O of 1 space complexity. So constant space. Now this solution is also not accepted because we have the same time complexity as this, the follow-up, but it has extra space complexity. Unordered map uses extra space, but we cannot use extra space. We have to use only this. We can declare some variables, but we cannot declare vectors. Okay. So how we can solve this problem? So this is a straightforward problem of Moore's voting algorithm. And if I start saying the traditional way, the definitions of Moore's algorithm, this will become critical for you. So I'm going to tell you a story, kind of we are developing a game or something like that, that has some rules. So let me tell you that we will have fight in some groups or within some troops of group. Like 2 is a team. There are 4 troops, number 2. And in this group, there are 2 troops, number 4. And they have number 3. So these numbers are some groups and they are the member. Let's say 3 has 3 members, 4 has 2 members, 2 has 4 members, and they will have fight between them. They won't fight each other, but they will fight with other groups. Okay. And this fight will have some sequence. Let's say, for example, this fight will be happen in an array sequence. Like, we will have 2, 3, 2, 4, 5, 2. These are some groups. Let's say 2, these are one group, 3 is another group. Let me say 3 is another group, 4 is another group, 5 is another group. And they will have fights. But the fights will have some rules. Okay. So the fight will be handled or happened from left to right. Okay. That means kind of we are iterating through left to right the array. Okay, so the fights will happen left to right. So this is the first rule, left to right. Okay. Second rule is all the right elements are much powerful, greater powerful than the left elements. That means 3 is more powerful than 2, this 2 is more powerful than this 3, this 4 is more powerful than this 2, and so on. For example, let me write another array. Let's say 2, 4, 1. They are going to having fights using these rules. So first rule is the fight will happen from left to right. So fight will happen in this direction. Okay. Second rule is right side elements will always win the fight. So let's say 2 and 4 will have fights because left to right, and 4 is the right element, so it will win the fight. 2 will lose the fight and he will die, and 4 will win. After that, we are having fight from left to right again, and 4 will fight with 1, and in that case 4 will die, 1 will win, the survivor is 1. So this is the result of this game. This game is 1 is winner. But there is another rule. What will happen if we have 2 elements like this and 1 element like this, or another element like this? Now they are in the same team. 2 and 2 are in the same team, so they won't fight each other. Okay, so if they won't fight each other, they will create another team that they are in same team now. That means 2 has frequency 2. Now this team will fight with this element. That means right elements will always fight alone, but left elements could have create some teams to fight with the right elements. So in that case, they have a team, but it is single. But still, we have said in the rule number 2 that right elements are the greater powered element. So in this fight, the right element will kill 1 element from the left side. It can kill 1 element from the left side, but also they both will kill this one. This is the critical rule of this game. I am repeating this again. They will team up when they have same elements. Then they will fight with the right element. The right element will kill one of them, but also they will kill, this group will kill the right element. That means the left element have team, the left team will decrease by 1. So in that case, 3 will be killed, 2 will be killed, these 2 will survive, and the frequency of 2 will become 1. So what will happen if we have 3 2s and 1 3 4 like this? So these 2 and these 2 will own fight each other, these 2 will own fight each other. So they will create another team. They will create a team, and the frequency of 2 is 3 now, and this team will fight with 3. Now what will happen? 3 will kill one of these 2, but 3 will also be killed by them, and the frequency of 2 will become 2. That means the frequency, the team member of this group is 2. Now 3 is killed, this 2 is killed. Now this team will fight with this 4. What will happen now? 4 will kill one of these 2s, but also they will kill 4, and the survivor of this game will be 2. These 3 are the major rules of this game. So first rule, fights will be happening in an array, and the rules is left to right. They will fight from left to right. Another rule, right elements are always be the winner elements. That means they have the most power than left elements. And the final rule is, if we have some same elements, they will group up. They will team up, and then they will fight with the right element. Right elements will always fight alone, but if the right element face more than one elements from the left side, right element will be killed, but one of the left elements will be killed also. So let's play this game using an example so that we have much more clear idea about the game. And let me give you a spoiler. The rules of this game is actually the Morse voting algorithm. Okay, so let us understand the Morse algorithm using this game, and then we will define the algorithm in the end of this video. Okay, so let's like 3 2 2 3 2 4. They will fight each other now. Let me write another 3 here. Okay, no offense. Okay, so first rule, left to right, fights. So let's the fight begin from the left to right. Second rule, right elements are the most powerful elements. So what will happen when fight with 3 and 2? 3 will kill 2 and 3 will be the survivor. Okay, so now 3 and 2 will fight each other. 2 is right side element, so it is most powerful. 3 will be killed and 2 is the survivor. Now we have another 2 and they won't fight each other. The frequency of 2 will become 2 and they are in left side. Now 3 will fight with these 2 elements. Now we have number rule that 3 is alone but they are in team, so 3 will be killed but 3 will also kill at 2. So the frequency of 2 become 1. Now there is another 2 we have find, and these 2 won't fight this 2, so their frequency increased to 2. And these 2 will team up and fight with this 4, and 4 will be killed, but 4 will kill one of these 2, and 2 is the winner. So this is the rules of this game. Now my question is, what is the worst case? So let's say I want to always win number 2 element. Let's say in this game I want to win 2 always. I want to win these 2 always. Now what is the worst case that this we can place these 2 elements? For example, if we place all 2s in this position in the starting, this is the worst case because all the 2s will be killed by these elements. The left side elements are in the weakest position. If we place like this 2 2 3 2 4 2, now what is happening? These are in the weakest position. These 2 can kill 3. These 2 can kill 4. Okay, but this 3-2 cannot kill a single troop or single soldier in this game. Everyone will kill them. They have to just survive. This is the worst case. If we want to make winner 2, and if we position 2 in this position, this is the worst case of this game, that 2 is in the worst position. Let's forget about the making 2 winner. Let's forget the making 2 winner. Just we defining the worst position of a element to win this game. So let's say 2. What is the worst position of 2 to win this game? This is the worst position. All troops, all 2 are in the left side. A single person, a single soldier cannot be killed by them. Everyone will kill these 2s. So let's play this game now. So 2 2 2 3 4 5. Initially all 2s will create a team. So frequency of 2 is 3. Now this 3 will have fight with this 2, the group of 2 with this 3. What will happen? 3 will be killed, 3 will kill 1 2. Frequency of 2 is 2. Now they will have fight with 4, 4 will kill this 2, 4 also be killed, and the frequency of 2 is 1. 5 and 2 will have fights, 5 will be killed and 2 will also killed. And sorry. In that case, 2 is a single person, 5 is a single person. In that case, right side element has the more power and it is alone, so he will be killed. 5 will be the survivor. So this is the worst position for winning. In that case, everyone is killing 2. Also they are dying, but they are decreasing the values. But when we have this 2 is killing this when this is survived. Okay, so this is the worst case, that you are positioning the 2s in the left side. This is the worst case. Now my question is, so I will place all 2s in the left side, that means in the worst position, but I want to make sure that 2 is winner. So my question is, how many elements, how many number of 2s we need? For example, n equal to 7. In that case, we have 7 positions. And my question is, how many 2 I have to place here to win the whole game? Everyone is against 2 and 2 have to survive the game. Let me start like 2, let's say n divided by 2 equal to what? Floor. 3. So let me start using 3 2s. Okay. So I'm taking you to the questions condition like n divided by 2 floor. So I am taking the exact value of n divided by 2 floor and trying to win this game. And other elements are 3, 4, 5, 6, something. Okay. Now what will happen? These 3 2 will team up. The frequency of 2 is 3. These 3 will fight with these 2s. These 3 will be killed. These 2 will be killed. And they will the survivor. Okay. Now 4 will fight with this group. 4 will be killed. These 2 will be killed. And the frequency of 2 is become 1. This 2 is survivor currently. Then 5 will fight this 2. And this 2 will be killed. 5 won't be killed because it is alone now. And 6 will kill 5 because it is right element. And 6 is the survivor. That means in that case, if we place all three 2s, that means n divided by 2 floor 2s in the left side, in the worst case, they won't survive the game. This is the case. Okay, let me increase it just by 1. Just by 1. The smallest element that is greater than n divided by 2 floor. 4 is the smallest element greater than 3. That means 4 is the smallest element that is greater than n divided by 2 floor. Now what will happen? I'm having 7 positions. 7 positions. In the first 4 positions, I am putting 2, and rest of the position 3, 4, 5, they are the competitors of 2. And these 2s will team up. 2 has 4 frequencies. These 3 will fight all these 2s. These 3 will be killed. 1, 2 will be killed. The frequency of 2 become 3. This 4 will have fight of these remaining 2s. This 4 will be killed. This 2 will be killed. The frequency will become 2. This 5 will have fight with these 2s. This 5 will be killed. This 4 will be killed. And this 2 will survive. That means 2 is the winner in that case. That means when n is odd, n is an odd number, and we are having 2 2s in worst position. The number of 2 is 7 divided by 2 floor equal to 3 plus 1. That means more than n divided by 2 floor. The 2 is winner in that case. And if we say another odd position here, let's say n equal to 9, what is going to happening? 1 2 3 4 5 6 7 8 9. So let's say I want to win an element like 2. I will position them in, I want to win 2, so I have to put elements 9 divided by 2 floor equal to 4 plus 1. Just 1 greater. Just 1, increasing the value by 1. Okay, just the smallest element that is greater than 4. So I am putting the 5, and these are the opposite or opponent, this opponent will kill this will opponent kill this will kill this will kill this, and this will be the survivor. That means if we have n equal to odd, we have to just put n divided by 2 plus 1 elements in the odds position, and our target element will be winner. That means our target element will be survivor if we put more than n divided by 2 floor values, number of elements in the odds position. Okay, and this is just by increasing 1, nothing else. Okay, this is greater than obviously n divided by 2 floor. This is the odd number of values. Now let's prove this for even number of values. N equal to 8. In that case, n divided by 2 floor is equal to 4. So we are putting 4 2's in the odds position, and others will be the opponents. Now these 2's will create team. For frequency, this 3 will fight with these 3 2's, this 3 will kill this 2, and the survivor is 3 2's. Then this 3 2 will fight with this 4, this 2 will be killed, the frequency will become 2, this 5 will fight is this 2's, this 5 will be killed, this 2 will be killed, the frequency of 2 is 1. Now this is single 1, this is single 2, this is single 6, 6 will be winner, 2 will be killed, and 6 is the survivor. That means if in even cases, if we put 4 2's, that means n divided by 2 number of 2's in the odds position, 2 won't survive the game. Now let's change it. Now for n equal to 8, n divided by 2 floor is equal to 4. We are increasing it by 1. That means more than 4. More than n divided by 2 floor values. More than n divided by 2 times. Okay? More than n divided by 2 times, n divided by 2 floor times, we are putting 2 in this array. 5 times. And these are the opponents. This is a team. In this team, frequency of 2 is 5. 3 will fight with this team. 3 will be killed. 2 will be killed. I'm cutting 2 from sometimes from this side, sometimes from this side. Don't confuse with that, because it doesn't matter for 2's. Anyone will be killed. No matter. Doesn't matter it. So 4 will kill this 2, and the number of 2's, 3 will be survive. Okay. Now 5 will fight, this will be killed, this 2 will survive, and 2 is the survivor, and 2 is the winner in that game. That means in even positions, in even number of even n, okay, if n is even, n divided by 2 floor is 4, we are taking just one extra element. More than 4. The smallest element that is greater than 4, the smallest element that is smallest number that is greater than n divided by 2 floor, we are just increasing by 1, and the 2 is the winner. So what is happening in another case? N equal to 10. So n divided by 2 is equal to 5 plus 1, just increasing by 1, more than 5. Okay, so we have 10 positions. 1 2 3 4 5 6 7 8 9 10. So we will have 6 2's, or 6 our target element that we want to make survive. This is 1 2 3 4 5 6, and these are the opponents. These are the opponents. So this opponent will kill this opponent will kill this opponent will kill this opponent will kill this, but we have 2 survivors. In odd value, n equal to odd, this is 1 survivor. In n equal to even, there is 2 survivors. But we have survivors. When we are putting number of elements n divided by 2 floor, more than, with increasing by 1. That means more than n divided by, if we have an element, if we have 2 in worst position, in average position or best position, there is more chance that 2 is going to win. Like 2 3 2 4 2 2 2 this is a good position. Okay, let me 4 6, this is a good position. 2 can kill this, 2 can kill this, this 2 can kill this. So this is a good position. But what is the worst position? If we have all 2s in the left, everyone will killing them. This is the worst position. But in that worst position, if we only have values and divided by 2 floor plus 1, just increasing by 1, just increasing by 1 in even position, in even number, or in odd number, just we are and divided by 2 floor, increasing this by 1, the worst mode, that means the lowest value that is greater than and divided by 2 floor. In that case, if we position these 2 in worst position, still this is survivor. Still this is survivor in this game. We cannot lose 2 if we have number of 2s and divided by 2 plus 1. The lowest value which is greater than and divided by 2 floor. Always 2 will be win. So what is, now my question is, what is and divided by 2 floor plus 1 number of elements? If f number a have frequency and divided by 2 plus 1, sorry, and divided by 2 floor plus 1, what it does it means? It is and divided by 2 floor. It is greater than and divided by 2 floor. So if an element in an array have more values, more elements, more frequency than and divided by 2 floor, it is called the majority element. That means in an array, if A is the majority element, if 2 is the majority element, if we put the 2 in the worst case, still 2 will be the survivor of this game. If 2 is majority element, then 2 is the survivor of this game if we put it in the worst case. If A is the majority element and we put all A's in the worst case, still A will be the winner of this game. And the rules of this game is Morse voting algorithm. So what is Morse voting algorithm? The Morse voting algorithm is, let's say 2, 2, 2, 3, 4, 5. First rule is we will iterate the array from left to right. This is the first rule of our game. Second rule, the left side elements will be the survivor, but left side elements will be the survivor. We have told it. And the final rule is if we have same elements, they will create a team. They will increase the frequency. They will have votes. And if we have, after that, if we have different element, it will be removed, and one of these elements will be removed, decreased by 1. Okay, so this is the Morse voting algorithm. Let's say 2, 3, 4, 2, 2, 4, and 2. So let me iterate through this using Morse voting algorithm. First rule is left to right. We are iterating. Second rule, the first element we are having 1 vote, okay, 1 element. Then when we are seeing that different element here, after going right side, we are having a different element rather than this. So now the majority element is 3, and this will be removed. After that, we finding 4, and this is different from the previous element. That means they are having fights. They are having fights because they are different, and the right side will be survivor. So it will have greater vote now. So we are writing 4. Now this is a different element, so we are writing now 2. This will be removed. This has removed. Now these are same elements, so the value will be increased. These are different elements, so this will be cut off, and one of these will be cut off, and 2 will have 1 frequency. And finally, we have found a 2, and the frequency will be increased. 2 is the survivor of this algorithm, and 2 is the answer. So if we run this algorithm or this game in an array, we have a survivor, and the survivor will be always the majority element. Why majority element? We have seen that if we position the majority element in the worst case, In the worst position, the majority element still survives this algorithm, survives this game. That's why this is proven that if we have a majority element, it doesn't matter if it is in the worst positions, it will survive the algorithm and we can return the value. Okay, this is the proof now, the theory. Now we are going to implement this. After implementing this, this algorithm will be more clear to you. So let's start. And then I will discuss the complexity. Okay, for this algorithm, we will have to have a variable named candidate, like who is surviving now. Like when we are writing this 2, 3, 2, 2, 4, 2. So first survivor is 2. 2 has frequency 1. Then it will have fight with 3. So first is 2. Then we are seeing this 3 is coming and 2 is gone. So we have to put this in a variable. Okay. So who is the current candidate or who is the current survivor? So integer candidate is equal num 0. So we are taking the first candidate. We are taking the first value, first element of the array as candidate. What we have done before, like this. So first candidate is 2, frequency is 1. So we have to write a frequency integer count equal to 1 because it has frequency 1, right? Now we will iterate through left to right. So for each integer a nums. So what is the condition? We are going through left to right. Okay. First condition is if we have the previous element, like 2, 2, 2, 3, 4. So we have the same element here. We have first element is 2 equal to 1. Then we are having same element in the 2 in the next position. What it does, it increases the frequency. Then we found 2 again, it increases the frequency. That means if we found the previous candidate, we will increase the frequency. If a if a equal candidate, the previous element, then we are not changing anything, just we are counting an extra. What is this? Like when we have initial candidate is 2, now found 2 again, frequency is increased. Now 2 found again, frequency is increased. Okay. What is another case? Another case is when we don't found the same element again. Okay. So for example, in that case, first case, let's say, first initially we have 2 1 times, now we have found 3. This is another element. So this 3 will kill this 2 or increment this 2. Okay. So count decreases. Count decreases if a is not equal to candidate. Now what happens? There is 2 cases when we decrease it. Like the first case and first example and the second example. We'll watch both together. In the first example, we have frequency of 2 is 1. In second example, we have frequency of 2 is 3. We have iterated through this and we got this. Now we have different element from the previous candidate, right? This is different element when we are here. This is different element when we are here. And we are decrementing the frequency. We have decremented this to 0 because we are decrementing the frequency. We have decremented this to 2. Just one decremented. Now what is the result of this condition in this position? There is no 2 survived. The survivor is 3 here. So we replace the candidate here, right? In that case, we replace the candidate. The candidate is now 3 and the frequency is 1. What happens in that case? In this case, In this case, so we have to write the condition. So if the previous candidate frequency is 0, we replace the candidate. We have to write the code. So if count equals 0, we don't have survivor of the previous candidate. We don't have any survivor of previous candidate. So we have to replace the candidate. So candidate is equal to current number. And the frequency count will be 1. And what is the another case? Okay, so this is from where, like when the frequency is 0, there is no survivor of previous candidate. There is no survivor of previous candidate, so the candidate is replaced. But there, in this case, the candidate survived. 2 candidates survived. There is some survivors from the previous candidate. 1 is down, but 2 is remaining. So this tree will be killed, and just the frequency is decremented, but no candidate won't be changed, right? So in that case, nothing will happen. That means the previous candidate will remain, count is decremented, but there is no other changes. But when count equal to 0, we don't have survivor from previous candidate. We have to replace the candidate, and the frequency will become 1 because we have one candidate, new candidate. Okay. And the final candidate will be survivor, and we will return that candidate. So what is happening in the whole example? Let me show you. So using both examples, so it will be more clear for you. Okay, so our first condition is we are going to left to right, iterate through left to right. So we are iterating left to right. So initially our candidate is first element and the count is 1. So our first element is our first candidate, 2 is 1. Okay, then what happening? First condition is if we have the previous candidate, we have to increment the count. That means when we are in the right side, we are going to left to right, and in this case we are found the previous candidate, so the frequency is increased. Again we found the previous candidate, the frequency is increased. Now what happened when we found a different candidate? A different candidate or different element, we will have fight. We will try to eliminate each other. In that case, this is sure. In both cases, when we encounter another element, in this both example, we will decrease the count of previous candidate. That means this will be killed, and among them, one of will be killed. This is guaranteed. From the right side elements, they will kill at least one. So this will be killed, also this will be killed. So the frequency of previous candidate will be decremented by 1. Will be decremented by 1. Now in this first case, the count is become 0, totally 0. So what will happen? The candidate will be replaced. Candidate will be replaced and new candidate frequency will be done. So candidate is replaced, frequency is 1, now 3 is candidate, but in this case 3 will be killed, but still previous candidate has survivors, so 2 will still survive. So in that case we are not doing anything, just decremented it and nothing else. After that, what is happening? In this case we have 2 again, and this is a different candidate. We are decremented this by 1, this is 0. We have decremented this by 1 because this is not the same candidate, and there is no survivor of previous candidate, so 2 will be the new candidate. So 2 will be the new candidate, and we have done it. When count is 0, 2 is the new candidate, frequency have 1. Now this is killed. After that, in this case 2 is same, so 2 frequencies increased, We are having the previous candidate frequency is increased. These are in the same team. We have different candidates, so frequency is decremented. But it is not killed still, so 4 is down, and new candidate is come, and the frequency is increased, and 2 is the survivor. And in this case we have 2s, and 4 will fight with them. 1 will be killed, 1 is the survivor. So we are having the survivor, and we know in this process, in this algorithm, if we have the majority element in the worst positions, still it will survive the whole algorithm, and it will be returned by it. And we don't have to think about the next case, that if we don't have, what will we do? We can just look through the vector and see if this candidate is the majority element or not, or something like that. So in that case, we will have always the majority element, and we will return it. Okay, so let me show you if this works. Okay, it passes the sample cases. Now we will submit it. Bismillah. And alhamdulillah, accepted. And it is 100% better runtime, in runtime. Okay, now let's explain the complexity. So what is the time complexity here? We are just iterating through the vector. That's why the time complexity is linear, big O of n. We have matched this condition. We have to solve this problem in linear time complexity, and the time complexity is linear. What is the space complexity? We didn't use any extra space, any vector, any array, any map, any set, just 2 variables. These are constants. So we have constant extra space, big O of 1. So we have solved this problem using big O of n time complexity, linear time complexity, and constant extra space complexity. This is the follow-up. And we have solved this using Morse voting algorithm. So that's it for today, and hope you enjoyed this video. If you like this video, please like the video, and please subscribe my channel, and please let me know in comment section if you have understand this problem, or what should we improve in these videos, and please tell me what you want to see in future. Okay, some video, what kind of video you want, and please join the group I have created. Please like our Facebook page. I have given everything in description box. Thank you so much. Assalamu alaikum warahmatullah.